So welcome everybody to the August edition of the Akri Developer Call. As usual, this meeting will be recorded and posted on the Deus Labs Akri Community Call playlist later on. So to get things started, let's start with announcements. Kate, you want to take the first one?
Yeah, so to start off, we are going to be participating in Grace Hopper as an open source project. And just a part of that is that when attendees can come to, they'll be kind of pushed in the direction of our GitHub and pointed to our issues, which we'll try to have a good set of them labeled good first issue. And then hopefully by the end of it, we'll have a lot of more contributors, and we'll also be able to help people who may not have a lot of experience in open source learn about that process. So in preparation of that, we need to get a bunch of good first issues up. So if anyone sees anything that they think could be improved about Akri, no matter how small, maybe not documentation focused changes, but anything other than that, they really want to move away from just documentation changes, please put up an issue and also point to exactly where the issue is. Try and be as verbose in the issue as possible, just so that'll kickstart someone's process with that. Yeah, so that's all for that.
Wonderful. So let's get started with the agenda. On to the first item, Akri on Crosslet demo. I'll pass that over to you, Rods.
Hello, John. Can you hear me well?
Yep.
Yeah, okay, let me just share my screen. Then we can get started. Yeah, it says host disabled, participant screen sharing.
Yep. Let me get you host access there real quick.
Awesome. I can then pass it back to you later.
Yep, no problem. Let's see the post.
Awesome. Can you see my screen now?
Yes.
Okay, so now let's get started. So hello everyone. Today we are going to be presenting Akri support for Crosslet and WebAssembly. This has been my intern project here at Microsoft for this summer. And yeah, talking a little bit about me, my name is Rodrigo Lemos. I'm a third-year computer science student from the Federal University of Pernambuco, and I'm located here in Recife, Brazil. So now going over for our agenda of this demo presentation. So first I'm going to talk about what the project's about. So talking more about the different technology and all the different projects we have used. Then I'm going to be talking some constraints in architecture. So more of like the challenge we face and how we overcome some of those. Then we're going to be doing a quick demo to show the project in action. And then we'll conclude with some next steps. So yeah, for everyone here, I think most of you are really familiar with Akri, but just as simple sample of what Akri does is Akri simplifies the discovery and usage of Leaf devices on the Kubernetes cluster. And this basically when I say Leaf devices, I mean small IoT cameras or small USB sensors and so on, things that you can access on an IoT environment. And this really helps the usage of them on Kubernetes as it creates workloads, and then you can start scheduling them to your Kubernetes files. So now more in depth on what Akri does. So there is a lot of components here, but I'm going to be focused around those that are running on each node. So there is the Akri agent and the discovery handler. So the discovery handler is for a specific protocol, needs to find these devices. So for example, IU, that discovery handler, is responsible for finding USB cameras on a Linux machine. So this is what this is the primary function of a discovery handler. And the Akri agent, the one that's going to be orchestrating the discovery handler calls. So the Akri agent will send to a discovery handler for start the discovery process. And as soon as the device has been discovered, it will contact the node so it can advertise to the whole cluster that the device has been created. So now more of like a new thing for a lot of Akri developers. So it's what's WebAssembly. So WebAssembly is a portable compilation target for programming language. And in fact, it was the compilation target for the web. So the web is really, mostly dominated with script language. So WebAssembly is here to bring a compiled alternative. And it turns out to be really high efficiency. So it's gaining a lot of popularity there with a lot of different improvements like low memory consumption and fast boot-up time. So the web is really taking advantage of that. But right there on the left, you can see that on the picture, we are using our WebAssembly code to be running on a Linux, on a Windows, and any other operating system. So this is what the WASI project comes from. So WASI is the WebAssembly systems interface, and it's meant to bring this type of improvements that WebAssembly is bringing to the web, but outside of it now. And then the final project that I'm going to talk about is Crossroads. So Crossroads is also an open source project from Days Labs. And it's a Kubernetes kubelet that lets you use WebAssembly workloads inside of Kubernetes. So since WebAssembly is not a Docker, the normal Kubernetes environment doesn't really allow and doesn't really understand what to do with a WebAssembly code. So that's what Crossroads comes in, and then it lets you use Kubernetes take full advantage of Kubernetes features for your WebAssembly application. So now a little quote from Solomon Hykes, the creator of Docker. And he says that if WASI existed in 2008, we would have needed to create Docker. And he's referring to right here about how the same WebAssembly code can be run in the same when your operating system or any machine, and it's sandbox. So it was all the motivation behind the creation of Docker back in the day. So of course, it's not saying here that WebAssembly is here to replace Docker, but it's just so a sense of how important the technology is and how much potential it can have on computing. So yeah, so now going deep into the project itself, the first part of it was all doing investigation and research. So I had to study and understand what a kubelet running containers compares to a Crossroads running WASI. And it turns out the same benefits and improvements we saw on the web, we can also see on the Crossroads environment. So for it still has a low startup cost and lower memory consumption than a normal container pod. So this is all really beneficial for the project itself. Then both of them has a really active open source community. So both of them can get evolved every single day, and there is development going on really actively. But Docker has a major advantage of that. That is, it's over 10 years of active development. So this means that the Docker and containers version, it has evolved a lot during this time, where WASI was only created in 2019. So there's a lot of room to improve and things that I still need to the community still need to develop. So most of the limitation that I'm about to say maybe will not happen anymore until 2 years from now. Maybe it just depends on the development of the project, but this is what we had to deal with during this summer. First, there is the single thread problem. So WASI only runs on a single thread environment. So what this means is we cannot have access to any asynchronous functionalities. And this really hurts application that needs to do multiple things at the same time. And the second one is the limited network access. So WASI has few network components that actually are integrated to it. So for example, it doesn't have access to sockets. It also doesn't have access to HTTP2, which is required to be running gRPC. So, and even doing a normal HTTP2 call is really challenging, as you need to run things outside of it to be able to run. And then finally is not every library can be compiled to. So for example, if your library has some sockets inside it, we cannot compile it to WebAssembly. So this really limits us the number of libraries you can use. It can slow down the development. So now more of like what we're trying to achieve with the project. So we are trying to bring Akri to Crossroads. And what this means is we're trying to bring some Akri components to be running as a WASI module inside a Kubernetes cluster with Crossroads. So we're trying to port as much Akri components as we can to the Crossroads environment. And by doing that, we are aiming for reducing Akri fingerprint. So Akri has already a really low fingerprint, but since it's designed to be running on the edge, we don't have a lot of resources like on the cloud. So we're probably dealing with a personal computer or a small server. So Akri can really benefit on improvements on this field. So we can make Akri more accessible and consume less of the user resources. Then there is the usage of devices on WASM. Of course, you can use devices on WASM today, but as we talked before, and I know everyone here knows, Akri really helps the development of the usage of devices on any program. So by bringing Akri to the WebAssembly environment, we are really empowering the WebAssembly community to develop more edge-focused application that can use these devices. So they can start creating new use cases for that. And finally, it's going to be growing the Akri community. So WebAssembly has a really active and growing community. And by bringing Akri to their attention, we maybe introduce new people that are willing to contribute for our project, and then that are willing to take part on that community. So now going over the design for our project. First, I would like to point to the Akri agent. So the Akri agent is in fact the same Akri agent that Akri uses. So nothing have really changed there. But you can see that instead of running it on Kubernetes, we are now running it locally. So since it's not a WebAssembly application yet, it still needs to run locally outside of the Kubernetes part. And another change is it instead of communicating directly with a discovery handler, it's now communicating with a gRPC proxy. And this gRPC proxy is here to mediate the communication between the Akri agent and the discovery handler. So since a discovery handler on our WASI build discovery handler cannot have access to gRPC stuffs, and this is the way of communicating the Akri agent uses, we have introduced the gRPC proxy that will print everything that the Akri agent sends into an input file, and then the discovery process for the discovery handler can start happening. So as soon as this device has been detected, it will then be printed to the output file. So then the gRPC proxy can send back to the agent. And then as soon as the agent take notice about these devices, it can inform the Crossroads node. So the Crossroads node will then create new resources about indicating these devices. And then we can even create a sample application that uses these devices. So now going over a little bit of the context for our demo. So our demo will be composed on 3 steps. The first will be running the things locally. So the gRPC proxy and the Akri agent that are not on Kubernetes. Then we're going to be running a WebAssembly version of Debug Echo discovery handler. So Debug Echo is a debugging discovery handler. So it's really, it's not a real device. It's kind of simulating the Akri discovery process. So this is what we're going to be using for the proof of concept of this demo. And then finally, we're going to be deploying a WASI application that uses the Akri Debug Echo devices inside there. So yeah, now let's go deep into our demo. So first, and the first part is showing off how the cluster situation is. And you can see that we only have one node. That's a normal kubelet one. So this will not be used during this demo. So we need to install our clustered one. So now we should have a cluster with 2 nodes, one of them being the clustered one. So yeah, so now our application is ready for receive WebAssembly workloads. So now we're going to be doing the Helm installation of Akri. You can see this is really similar to the one that we always have been using for Akri, but we are setting a lot of components to set false. So what this means is we are not deploying anything to the cluster, like any pods or any daemon sets and deployments. We are in fact just using the Akri configuration to installing the correct CRDs and the configurations files. So for example, on the last line here, you can see that we are setting the Debug Echo configuration to be enabled. So this means that the Akri agent will start already looking for Debug Echo devices. So now let's start our local agent. And you can see that the agent has already started looking for Debug Echo discovery handlers. But since there's no registered one yet, we still it will keep waiting for one. So now let's run our proxy. And as soon as we run, you can see that right there on the second line, we are specifying the discovery handler name to be Debug Echo. So this proxy has been created to work on any WASI build discovery handler. So we need to specify what discovery handler this is referring to, so it can connect to the agent correctly. So right here, we are specifying to be Debug Echo. So the agent will know this gRPC proxy is capable of finding Debug Echo devices. So as soon as we run, and since the agent is already looking for Debug Echo devices, the connection has already been established, and there is even an input file already written. So now let's move to the Kubernetes part. So now we're going to be deploying our WebAssembly discovery handler for Debug Echo. Right there, you can see the YAML file. One cool thing is the node selector part, where we're specifying the Kubernetes architecture to be WAS on 32 WASI. So this will be deployed to the Crossroads node. Also, one cool thing to notice is the volume mask that we are adding. So right there, we are adding some volume masks to the deployment. And this is the directory that we're going to be using for communicating between the gRPC proxy and the WebAssembly discovery handler. And even though temp is a globally directory, so any user can have access. since WebAssembly is sandbox by default, we still need to specify it directly so it can have access during runtime. So now let's apply this YAML file. And then we can wait a little bit for the output file to arrive. So what this is doing is that it will read the input file, and then it has already printed the output file. So the agent should already receive it, the devices. So then you can see that the Akri instance has already been created. So there's two Akri debug echo instances right there, and they are visible by the Crossroads WASI node. So we can start. So now you can start deploying a sample application that uses these devices. So for this, we're going to be using this deployment right there. Let's wait a little bit. So right there, you can see that also on the node selector part, we are specifying to be WASM32 WASI. So this will also be deployed to the Crossroads node. But right there on the resources part, we are specifying that we need Akri debug echo device as requests. So this pod, in order to run, should have access to our debug echo device named exactly as this. So now let's apply it. And then we can check to see if it's running. So yeah, it's running right there. And then we can start the logs and see what it's doing to the debug echo devices. So yeah, it's running, and then it's the debug echo device name full one. So it has correctly accessed the debug echo instance. So now moving on for the takeaways from that. First, we have used a debug echo discovery handler. So a little comparison between the container version of debug echo with the WASI version. First, there is a massive decrease on file size. So previously, the binary code for debug echo discovery handler was 12 megabits. Now the .wasm file is 172K. So there is a really massive decrease there. Of course, we can maybe see a little increase on this file size as WebAssembly evolves, and we need to add more things to the to our program itself. But even though this is really a powerful solution that can really decrease the file size. So now there is also decrease on startup time. So the startup time previously was 4 seconds, and now it's averaged at 3 seconds. So kind of like a 25% decrease there. But most importantly, the biggest takeaway was the usage of Akri devices on Crossroads. So now you can start creating WebAssembly applications that use the Akri device and Akri facilitations. So yeah, so now let's conclude with some next steps. So first and more immediate one will be the creation of new discovery handlers. So for this demo, we have used debug echo. So, but since debug echo uses fake devices, we are really needed to create a new discovery handler that correctly discover proper devices on the network or on the machines. So we have some experience with Onvif and Untitled, and both of them seems doable on the WebAssembly environment. And then this can create real high impact on the WebAssembly community. And later one, and a more long-term one, would be the bringing Akri agent to WASI. So the Akri agent, bringing the Akri agent right now to WASI is really a challenging task, as the Akri agent needs to communicate with a lot of different components and needs to do multiple things at the same time, which is really hard to do on a single thread no-network environment. So we might need to wait a little bit for the WebAssembly to develop more to make this possible. But this is still in our minds, and we can empower even more the WebAssembly community. And finally, the final one will be to bring everything on Kubernetes. So nothing will be running locally anymore, and we can start deploying the things with Helm, so the user can start using Akri with no friction. So yeah, thank you so much for listening for the presentation. And of course, everything is open source on GitHub, and you can start contributing to the project right now. Right there is the link. Any questions?
I guess there aren't any questions, but Rods, thank you so much for that demo. It was amazing, and I'd love to see where WASM and Akri kind of move forward along in the future. Moving on to the next topic in the agenda.
Thanks, Eric.
Thanks, Rod. So moving on to the next item, we have Onvif Updates. Kate, do you know who?
Yeah, sorry, that's me. My network's a little bad. Is everything okay? Can you hear me now?
Mm-hmm.
Great. Over this past month of our, I think people are a little frozen for me now, so please let me know if you can't hear me. But a part of those optimizations were previously the Onvif discovery handler required 1,300 Kubernetes CPU units. That was like the limit when we were creating our deployments of it, which is the equivalent of like 1.3 cores that the discovery handler, Onvif discovery handler pods were allowed to use, which is a lot. And so the goal was to get that down. And by the end of it, now it's down to 22, I believe, CPU units, which is 0.002 cores or something. And part of that was one of the big parts was when we discover cameras, we do also some additional filtering, such as what are your scopes and what is your MAC and IP address. And so moving those out to be only done the first time the device is discovered. And then filtering out any devices that do not support those endpoints so that we're not continually pinging them and not receiving responses. And so some interesting discoveries came out of that. So for example, authenticate cameras that require authentication don't support calls to get network interface, which is the endpoint that gives you the IP and MAC address of a camera. And so we have an issue up on Akri to support discovering authenticated cameras. And part of that means creating a story for passing credentials to the discovery handler or brokers that are using these cameras. But more so before even handling that, it'd be great to discover the cameras and allow brokers to connect with their own credentials. But that is inhibited by the ability to get a MAC address for a device. So there's some discussion happening there. If you would like to join it, it'd be great to get some more input under that as well. Additionally, with the improvements, we also made some changes to our Onvif Broker, which was very large. Previously, it was 2 gigabytes for this broker. This is a sample broker. It's mainly for our end-to-end demos and just documentation walkthroughs. And so there were some optimizations that brought that down to 800 megabytes. So just making that sample more easily used on people's lower footprint environments. And that's about it for Onvif improvements. The only other thing to bring up is with Onvif, we did some investigation on supporting IPv6 cameras. We have an issue up discussing that. Previously, currently we're able to discover IPv6 addresses, cameras, but we then are having difficulty gaining access to their endpoints to check aliveness and do that filtering that I mentioned. And part of that's because we're discovering their local link addresses, and then we don't know the interface that they're on for then next connecting with them. So some investigations happening there as well. But those are Onvif updates. Are there any questions with regards to anything with Onvif? Great. And those changes will be out in the next release. So more optimized. So very exciting.
Cool. I'll be looking forward to see those updates. On to the next topic. We have the documentation repository, and then talking about different locations where it might be where the code can live for the documentation website.
Yeah, I can speak to that as well. And Edric, chime in if you have thoughts on this too. We are looking to move Akri's documentation into its own repository. Partially this is that's a convention that we also want to join in on is one of the reasons. And the other is we want to serve up our documentation via Gitbooks, and it will be easier to manage and format in its own repository. But the question that we have is we have a proposal section of our documentation that is more technically focused, and kind of curious whether that should be, first of all, part of our Gitbooks. Should our proposals show up in our general like user documentation and developer documentation, or should those only live in HackMD, for example, or in one of our 2 repositories, whether our main one or our documentation one. So I was just curious to get people's thoughts. I personally like the having the proposals be a part of a GitHub repository, because then you can create a pull request with one. There's a clear area where people can have comments and build off of each other. And just to give an example of what some of these proposals are, is, for example, if you're creating a discovery handler, you would want to create a proposal. So currently we have proposals for ZeroConf and the ones that we've already implemented. And then there's a proposal there's a pull request in for right now for MQTT and for co-op for devices in constrained environments. And so we've been able to comment and kind of get that proposal fleshed out via a pull request. So that's kind of my preferenced form. But there also could be points made for having it live on our HackMD. Do people have any thoughts on that?
I think both both cases are valid, and I definitely do see your point with having it on kind of included in GitHub, in the GitHub repository, so that it can be tracked and kind of stays a version of history. I'm curious if there's any way to kind of have it in part of the repo, but not served up on the main website itself, even though it lives up on it lives in the same repo, but not have it that the proposals, anything that's like tagged the proposal or in the proposal folder, not be served up by Gitbooks. Or I don't know if anybody has any thoughts on that, like with all the incoming proposals, should that be something that just like lives specifically inside the repo, and you'd have to go in the repo to view it, or it'd be something that is a section on the actual docs website where you can go and check it out?
Yeah, I think that's a good hybrid approach. Having a repository with like a docs folder that's served up on Gitbooks, but then another folder that's proposals, so that we can still keep all of our documentation in a separate repository, but not necessarily have our proposals be a part of our user and developer documentation. That seems like a good balance to me. I'd be curious what other projects do. I think some have, I'm thinking of really big projects, like Kubernetes having separate repositories for proposals versus like their doc site. But it might be good to do some looking around as well.
Mm-hmm. I think with other big projects too, kind of like Kubernetes too, right? When they're big enough where, I guess currently we live under the Deis Labs organization, but for something like Helm, where they have their own organization at GitHub, they just basically spawn off a whole bunch of different repositories within their organization. So I think with Helm, they have a Helm/community section where that's just like solely for the purpose of dealing with like proposals and community related things. But you know, since we live under Deis Labs, we kind of have to find that balance in between, I suppose.
Yeah, that makes sense. Great. Well, if anyone has any other thoughts on that, feel free to put up an issue or put it in the Slack. We'll probably start that process pretty soon. So excited to have a documentation website.
Wonderful. So going through the agenda items, next on the list is issues cleanup and whether or not we should have a stale issue bot.
I can start us off on that, and then Roa might have some thoughts on ideas for that. But we have a lot of issues in Akri, and some of them have been around for a while. And so just kind of taking a look at all of them and seeing like, have they been addressed, closing them out. We don't have a clear workflow for all that. A lot of projects use bots to mark things as stale or automatically close them out. And so kind of thinking about what should we do for that? Should we implement something similar? Should we make a bot or use a bot? Wondering if people have any preferences on kind of using that automated way of responding to issues getting older, versus kind of keeping that being a fully manual personal process?
Yeah, I think there is a couple of questions here. So yeah, I think it's kind of a common thing for people to have like a bot that automatically tags or handles issues that are stale. We already have an Akri bot that takes care of auto updating our dependency and doing our security audits, so it's easy to extend that to do that as well. I think the question is, how old should we start marking the issues as stale, and what is the action like to do when they're stale? Do you want to just mark the issue, add the label that's stale? Do you want to close the issue? So I would love to get thoughts on what everyone thinks about that. My proposal would be just go with the 30 days as a way for kind of nudging the hoster if they want to kind of follow up on the issue. And the bot can mark the issue initially as stale by adding a label and adding a comment in the issue. And then any comment afterwards can automatically activate the issue if you want. Kate, others, any ideas here?
My only thought about the comment afterwards, reactivating the issue, is what if the comment says, yes, this is stale? I guess then we manually close it.
Yeah, actually, I didn't elaborate that. Usually the convention is people would add a comment with a specific keyword that say reactivate or something. So that would be how we can reactivate the issue. So yeah, thanks for pointing that out, Kate.
Cool. No, that sounds like a good balance. Yeah, and then I guess your question is how long, what do we define as stale? I feel like that is probably something we can see what others do, but in my quick thought, it's a month. Do other people have thoughts around time?
I think on top of a time parameter, there's also maybe something like issues can only be marked stale if one of the maintainers or somebody has actually commented on it, right? Like if just to make sure that like somebody's actually looked at it and kind of thought it through, but then like if there's nothing done about it.
That's fair. Like making sure there's a difference between stale and unresponded to. Yeah, so if that's the case, we should have something alerting people to respond rather than just doing nothing. So I know you can have Slack bots that will bump people or email people. So maybe we do something like that for those scenarios. Hopefully that doesn't happen, but maybe it could, yeah.
Yeah, I'm also thinking that maybe we can use the, I mean, we usually have, like, whenever we have time in our community call, we do triage the issue. So, so since this happens monthly as well, maybe that would be a good practice to make sure that we kind of scan the inactive but like issues and make sure like that's the right action for those ones if we have time. But at least that would handle the scenario where Edric mentioned. Hopefully that would never happen, but just in case, that would be like a plan B to make sure nothing falls through.
That makes sense, yeah.
Cool. And I think moving on to the next agenda item, we have a broker deployment strategy discussion, where and how many pods should be deployed to discovered devices. Let's see if I can pull up the link to the GitHub page.
So I can start us off on that one. Currently, Akri has one strategy towards deploying brokers to discovered devices. And brokers are just what we call the pods that our controller automatically deploys. And that's kind of a daemon set or microservice approach. And this documentation right here that Edric's pointing to is from our proposals folder. And with our current deployment strategy, it's just every node that can see a device gets a pod deployed to use that device, or a broker deployed to use that device. And the number of nodes that can be using that device with a pod at once can be limited via capacity setting in our configuration. So if you say you have 4 nodes, all 4 nodes can see some IP camera, and you set a capacity of 3, then a broker will be deployed to 3 of those 4 nodes. And furthermore, if that broker goes down, we spin it back up. So we have this assumption that you want your workload to always be interacting with that device. So this is clearly one specific scenario, and we want to start building Akri out to support other deployment scenarios. So this documentation points to a few, but I would love to also hear if people have other scenarios that they envision for Akri that they want covered, because we want to do some work to provide general infrastructure in Akri to continue to support new deployment strategies. So to name some, we have our current strategy. We also could have a strategy where you deploy one workload to multiple brokers. One workload to multiple devices. So if we scroll up a little more, Edric, we call that instance pooling, which is the second section. So you can imagine something where, say, if you wanted one broker deployed to 3 cameras, you would set an instance pooling field. We're definitely going to flesh this out a little bit more, but an instance pooling field could be 3, and that means that you want to have 3 cameras be utilized by 1 frame server, for example. The question with this becomes, if we scroll down a little, Edric, if you have 5 IP cameras, what do you do in that scenario? Do you have 1 broker deployed to 3 and then nothing deployed to the other 2, and create an approach where you have to have exactly that number in order to have a broker? If a camera goes down and there's only 2 now cameras for that broker, do you then bring down the broker? So some considerations with that too need to happen. Some of the ways we could do this is we could have that really strict policy where we only deploy when there's 3, and if that ever changes, we bring down the broker. Or we could have a config map that can make it more dynamic, so that we can mount into the brokers so that they can know what cameras they're accessing at any given moment. So a few options listed there. If you scroll down more, another deployment strategy may be resource grouping. So having one broker be deployed to 2 different types of types. So types discovered by 2 different configurations. So say you want your end application, some ML processing application, to utilize 1 GPU and 3 cameras. How can you specify that in a configuration? And that strategy we kind of are calling resource grouping. So that's another one that would be great for Akri to support. Another one is the idea of deploying jobs to use the devices. So I mentioned earlier that we currently have an approach of keeping that broker up so long as we can see that device. Instead, what if you have some job that you want to connect to the device, do something with or on the device, and then bring that job down? So supporting that. And then finally, if we go down, it would also be great to support exposing devices at the configuration level. So currently, if you deploy, say, an OPC UA configuration to discover OPC UA servers, industrial machinery, each one of those servers that's discovered will get its own instance. And then if you were to not use Akri's controller and instead deploy a pod of your own to use those Akri resources, kind of like in Rod's demo, then you would need to specify the configuration name and a hash of the instance that was discovered. So a very specific device. It would be great if instead, if we scroll down a little, you can just specify, oh, I want to discover akri.sh/opcua server, for example. And then we reconcile exactly which one for your pod to use. So that was a quick run through of some of what's explained in this document. But I would love to hear if people have other scenarios that they envision using Akri that don't fit one of those spoken deployment strategies, and also which one of those strategies is most exciting to people. Ideally, we'll support all down the line, but it's building out the plumbing for that.
I don't know if it fits into deployment strategies or not, but I've always thought that being able to somehow combine configurations would be cool. Maybe that's not a deployment strategy. Kind of feels like it's a little bit deployment, but like you might want, I want to see an Onvif camera and have a GPU, or Onvif and something in the UDEV system. But I don't know.
So having one configuration where you're specifying kind of that resource grouping scenario instead of having two.
Yeah.
And in that scenario, would there be one Kubernetes resource created to represent GPU plus camera?
I think so, right? Because I want to be able to target a workload to that combined thing.
Why not use resource grouping to do that instead of a combined configuration?
I'm not sure. I don't have a good reason other than it feels more natural to me, but I don't know if like I don't know. I assumed that resource grouping was more of a combination of like things. Assumed is the wrong word. That's what I took from it. But perhaps.
Yeah, I think of instance pooling as that. I see that being the delta between instance pooling and resource grouping. These are also just, we can rename what we call these different strategies. So if that's confusing, I understand. Do people have any other thoughts?
At some point, we also talked about having kind of a, instead of a daemon set version, having a deployment version or a replica set version. So for example, we talked about, you mentioned if there were 4 devices and you had a capacity of 3, that 3 of the 4 devices would get a broker on it. But if you had 2 devices and a capacity of 3, maybe you actually want 3 brokers deployed, right? So really what you want is a replica set, or a set of replicas, right? Where maybe one node gets 2 of them and another node gets 1. So you end up with 3 actual brokers running. I don't know, it's another thought.
Yeah, that's I skipped over that one for sure. I think it's in this proposal too. That makes sense, especially for high availability of those local devices too. So some USB camera, maybe you want to have 2 workloads using it on the same node, so that if one goes down, you still have the other one using it. So that makes sense. Awesome. Well, if there are any other thoughts on this, feel free to drop them in the Slack. It'd be great to hear about the scenarios that they're excited about with Akri, and make sure those are being considered.
So I think in terms of the agenda, that's all the items we have. I guess we can hop over to issue triage then.
Yeah, unless anyone else has any items they want to bring up now. Or any questions or anything.
Sounds like we should do issues.
Let's do it.
Wonderful. Brian, should I give you, I'll give you host access.
Yeah, that'd be great. Share. Okay. So it looks like we have six issues with triage needed. Just jump right in. The first one, execute workloads based on labels instead of flags and PR titles. I think generally speaking, I don't know, I think this should just be, we should move this over to in progress, right? Is this being worked on, or I thought it was?
Yeah, I think Vince is working on it. And I think is on the call if some context wants given on it.
Yeah, Vince, do you want to speak to this at all? Okay. Well, maybe we can just move it into in progress then. Does that work?
Makes sense.
Or I can try to and fail.
Looks like Vince just chatted, put in the chat that he'll have a PR out for it shortly.
Cool. Let's see. Why can't I move it?
Try just moving it. Oh,
That seems
I
like
can see if I can do it on my end. I've got it. I'm moving it.
hot dog. All right, thank you. The next one we've got improvements to the it's implementing discovery handler. Let's see, I'd like to move to that tab, but Zoom is blocking me. So this looks like just some docs enhancements. It seems like a great thing to do, and I don't see a reason to not do this. Should we move that over to backlog?
Yeah,
We
that,
also
that makes
have a
sense.
documentation tag, Brian, if you want to add that.
Good idea. Let's see.
You're not signed in. That's why you cannot do anything.
Ah, it's brilliant. Sorry, on a different computer. Let's see.
I can go ahead and add the documentation tag.
Cool.
Great. I just added it.
All right.
And I'll move
Great.
it to, I'll just do whatever you vocally tell me to do.
Perfect. Okay, switching from MIT to Apache license. Sounds like we need to do it. So let's move that over to backlog.
All right, I'm moving it. I'm trying to see if there's any labels on that. I don't think so.
Can't think of what it is. It's not really documentation, is it? Is it kind of documentation?
Yeah, that's gray area for sure.
Okay, cluster setup flow for micro-K8 points to 1.19. I guess we could make it more general so that it doesn't pick a specific micro-K8, but we really kind of have a set of micro-K8s that we support. Do we want to update this every release or every time we reevaluate which versions we support?
Yeah, I think there's two sides to this. Like if we have our documentation point to the latest stable channel of like micro-K8s, K3s, etc. That means that if people run into issues, then with that version, then we'll get issues put up on us and can provide support faster. But that is a part of our release cycle to test the latest versions and update our workflows to use them. So I think there's either way to that.
I sort of feel like it makes more sense in our documentation to reflect what we know we support than to say we support the latest stable and then use that as kind of a testing mechanism. Right? Have our users be like, wait a second, I tried this and it didn't work. But that's kind of just my leaning.
I agree. The only thing I would say is, say you already have. Yeah, I think and I think we can decide at some point, like if we want to put a won't fix label on it or not. And we should come back to it soon on.
Okay, why don't we stick it in investigating for now then, and we'll keep it in mind, I guess.
Okay.
And looks like we have a security issue to work on.
So this one we're blocked on patching because it requires to increase our Prost version, we have to increase our Tokyo version, which is along with all of that other issue we have. So I
Right.
linked them together.
Okay, so this is a bigger deal, or a bigger change.
Or yeah, it's not huge in itself. It's small if everything else is there, but it's we're blocked on making that increase because of Kate's open API patch that needs to go in. So it's just not.
That's for the CRDs and kind of its new auto handling of types, right?
Yeah.
Is there a way
Kate's
to
open
do the old
API.
methodology with the new, like, so
No.
can
Yeah, they completely updated their API so that you can't use the old format of creating CRDs. It's more that their CRDs, the way that it's a really niche thing where you can't have a Kubernetes type within a CRD without there being a like JSON schema parsing error. And they're working on a fix for that.
Okay, so I think this has to go into the backlog then, right? Just sitting on this other change, and they're linked, so that's okay. Is there, there's no way to actually, the link is only in the comments, right? There's no way to actually link them. There's no link section in the issue. I don't see one.
Yeah.
All right, and let's just move that over to the backlog. We've got Akri architecture for IoT protocols with standalone devices. Sounds like this is looking to leverage a methodology that's less dependent on device plugin.
Yeah, this seems like a discussion. I wonder if we should put the question label on it or.
Question label. Sure, sounds good to me. Is this something that we should maybe open up to a discussion during one of these meetings to try and get some ideas here, or is this is there an actionable proposal that can come out of this?
Yeah, I think this is still in the, I'm still trying to clarify what the discussion is here. I think right now as an issue, it's a good conversation. I'm not sure if it's come to a point where we're ready to discuss if a change needs to be made or what the exact need is.
Okay, sounds like it needs to be moved into investigating. Would be my take on that.
Yeah.
All righty, I think those are all the issues. We hit the refresh button. We're triage free at this point.
Wonderful.
Yay.
And that brings us to the top of the hour. So thanks everybody for coming, and we'll be looking forward to seeing everybody in the next Akri developer meeting.
Thanks, everyone.
Thanks.
Bye.
Thanks,
Bye.
bye-bye.